Hello everyone and welcome to this live. In this live I'm going to be building a handheld Raspberry Pi based on the board you're seeing here. This is a Raspberry Pi 3A Plus. And yes, you can actually buy these right now in 2023. To check your local reseller, just go over to rpilocator.com and you'll find a list of retailers. But if you're in the UK, currently Pi Moroni and the Pi Hut are selling these. So this is now me building a case. I have the 3D printed top here and I have a freshly 3D printed base case as well. So I've gone for a nice yellow and blue theme. Just because I'm bored of black and boring slabs of glass like this phone here. Boring, right? Let's go for something more colourful. So I've actually got a couple of Raspberry Pi 3A Pluses there. Have you got recommendations for more small external displays? The display I am currently using is this one here. This is the Hyperpixel 4. Now, if you're talking external displays, HDMI ones, I don't have anything off the top of my head right now. However, I have just ordered one as part of another Raspberry Pi project that is HDMI driven, so stick around for that. And maybe in the next week or so, you'll see that video going up. And I've managed to get my hands on quite a cheap display that could also be used to extend your computer display if you wanted. What happened to the previous one? The one had the problems with the SD card. SD card was the problem. So this one is now working with an SD card. If you're talking about my Raspberry Pi 4, that one's still dead. I don't think I'm delivering enough amps into it, and I think that's why it's not powering on. But this board, everything you see here is set up for 1.5 amps driven, no problems. So in this project, I will be powering it with a USB Type-C. This is a TP4056 board. This is a battery discharge and overcharge and charger protection board. So this will then power this 18650. This is a protected or PCB protected battery bank with 2,600 milliamp hours of capacity, or it will deliver 9.62 watt hours at 3.7 volts. Now, of course, a Raspberry Pi will take 5 volts. So at 5 volts, 3.7 isn't going to work very well. So I'm using this DC to DC converter. Basically, by twisting this little screw here, you can raise the voltage up to 28 volts, or you can raise the lower voltage up to 5 volts. So this one's already been pre-configured. I will test it with my multimeter before I go forward, because it has not been run recently. Now, my question is, where's my multimeter? There it is. I'm semi-organized today. So I will be testing the output before I actually solder it onto the Raspberry Pi. To power the Raspberry Pi itself, I will be using these two leads at the bottom. So I'm just going to turn on my zoom cam, which is this one here, and I will give you a close look once I find where I've dropped it. There it is. So literally all I've done here is underneath the micro USB connector, which is currently powered in there, I have 2 wires soldered onto these PP pads. Now, people love it when I say PP for some reason, but this is PP5, this is ground, and this is PP2, which is the positive lead. This will take a 5 volts in. Now, you can also attach voltage directly to the GPIO pins. There is a 5 volt and a ground you can attach it to as well. The reason I'm doing it on this side is because if you look here, there's actually power protection. So if there's a surge or something goes wrong, this fuse will go before it takes out the rest of the board. And that way we got protected power delivery directly into the Raspberry Pi. So now you've had a bit of a look at that. We'll hide this camera. Is it possible to switch the camera view to the other side? Comments are covering. Yes, but it's going to be a bit finicky because I've also got my display on this side. So I kind of got everyone set up. But I tell you what I can do is drag this over here and we'll just run one at a time. So there we go. So we'll hide this one. And now you can see that. So basically, this is the Raspberry Pi. Before I began doing anything else, I plugged the Raspberry Pi into HDMI and I made sure it booted. Because I have, before now, started a live with a Raspberry Pi, expecting it to work, and I had killed it in a previous project without realizing. So, as we can see, this is now running off a normal power supply directly into the connector. So the idea is to convert it over to these other ones. So I'm going to disable my Raspberry Pi view right now, so we get a full list of the desk and what we're doing. Yeah, we basically proceed from here. I'm just going to power this off now, and now I know it's working fine. I can disconnect everything and I can start fitting it to the case. So right now I'm going to move these things over here slightly, and we're going to start by fitting our Raspberry Pi. I've already pre-soldered the leads onto this one. Thank you for the follow, I really appreciate it. Please like, follow, subscribe, and remember this will be going on my YouTube channel as well, which is YouTube at ckenthusiast.com. Alright, so I need to cut this wire back so they're about the same length. So let's start there. I'm going to trim this one back as well. And this is a nice soft silicone wire, so all I've got to do is grab my clippers and kind of pull like that. So it's nice and simple. This will be soldered directly to my... I'm going to work backwards through the circuit. So the battery is the last thing I attach to everything because I want to make sure all the soldering is done first. But the first thing I've got to do is desolder these parts. The reason being, I want the wires on the top of the board rather than the bottom of the board. But before I do that, let's test the pre-assembly. Let's make sure everything works well. I'm going to take these wires here and I'm going to put a dab of hot glue on it to try and keep those wires in place. So I'm going to hold that for a moment while it settles down. Just hooking my gun back on its hook. There we go. So this would hopefully stop the wires from flailing about too much. It's non-conductive and I've aimed so I'm not covering resistors or anything like that. So that seems pretty solid now. Yep, that's dried. And it should be over the gap here. So I might need to shave a little bit off that if it's settled nicely, but there we go. So that's now a little bit neater and these wires are coming out a little bit more organised. In fact, this one's now actually a bit too long, so I'm going to trim this one back as well. Like that. Twist it. Hot glue will not hurt the board, no. Remember, it will take solder from a soldering iron, which goes up to 440 degrees. Hot glue is a lot cooler than that. The glue itself is not conductive, so it's not going to hurt anything. It's either that or I just killed a Raspberry Pi. So that's now trimmed a little bit more neatly. So this will now go into the board like this. And as you can see, the Raspberry Pi fits quite snugly. All the screw holes are aligned nicely. So now I've got to bolt it in. So I do have a box of bolts here, which I will now bring out. So I'm going to use an M2 thread, even though it's an M3 hole, because I don't have any M2.5s, which is what these little stands will take. So this is kind of a temporary measure, but I will bolt it in using this method for now, because the final piece that comes down will hold everything together anyway. So we'll begin by threading this through. Power supply pin didn't work. This is going into the power supply pin. So I'm just going to put that there, put a washer on it, and then I'm going to put a little nut on. And for this, I tend to like to use my tweezers because it gets a bit fiddly. And I'm going to grab a little bag of nuts here, as you can see. And I'm just going to bolt it in at the corners. So this does get very finicky, and my hands shake a little bit. Oh, that's just all dropped out. Of course it did. So put that through again. Grab that. Get the nut on there. And then just rotate it with the tweezers. Then I will grab my needle nose pliers. And do I have a small hex for this? No, I'll probably put it somewhere else. So what I'll do is I'll grab my other toolkit. I'm not powering it by GPIO, I'm powering it by the test pad pins at the bottom, because that goes through the protected circuit. I don't like powering it via the GPIO if I can avoid it. So I'm just going to hold this bolt with my needle nose, and I'm going to give it a twist here on this side so it's nice and secure. There we go. Right, so there is a bit of a lift in the board there, which is probably caused by the glue. So now that I've tested that, and I expected that to actually happen, I'm going to shave a bit of the glue off. Or actually, if I just... No, it might actually be because I pulled it down a little bit hard on the screw. So let's just not tighten that quite as much. There we go. That should be fine now. Yeah, and if I just screw it down on the other side, it will be nice and flat. So we'll repeat the procedure on that side. Not sure how many of these long screws I've got. Unfortunately, it's the most popularly used. That's a bit short. That one. I've got some that are too long, some that are too short, and I may actually be running out of the ones that I need. No, there's one, I think. I need to get some more of these M screws. Yeah, that's fine. That's the same one. So once again, same procedure as before. I'm just going to drop a little washer onto it. I'm going to use the tweezers. Like so. Oh, there we go. Did it perfectly the first time. There we go. Come on, come on, get on there. Come on. There we go. So same procedure as before. Bolt goes on top. And I've got to turn it with the tweezers to get it started. would be easier if I had a little sort of over the top screwdriver. There we go. But it does kind of work this way. It's a bit of a pain to get it started. But once it's started, it's easy enough. So again, same procedure. Hold the bolt with my needle nose. And then screw it in the other side. There we go. So that's now pretty firmly in there. I think I've got another one. Is that one long enough? No, that one's too short. So I need the longer one. That one. Is that one too long? Kinda. No, actually no, it's about the height of the other ones. Okay. So a little washer. Bolt. Get it started. And pliers and screwdriver. And then just one more to go and it should be secure. Though that's pretty. That's definitely not going anywhere. Let's see if I've got one more left. Do I have one more left? I think this one will do. Oh no, that's way too long. Though actually it should be fine. We'll put a way too long on there because that will help steady the post that I put down on it later. Hopefully, so that I'll have to remove it. Another one of these little nuts. Then on it goes. Get it started. Then again, hold and screw down. There we go. Inspection of the board. I haven't knocked off any resistors or done any obvious damage, so we should be good. Get my micro camera. We'll turn that on. And as you can see, these are all screwed in. And that should be good. Right, put this back in the bag, and that's now the Raspberry Pi installed. That wasn't too painful. So now all I need to do is put the extender on for the screen. Like so. And now I need to add the bolts to the screen as well. We're going to be using these little standoffs. Just want to make sure that this one fits over that screw okay. Yep, seems to. And we'll see if we get this connected. So I'm basically eyeing the pins from the inside. So if I turn this on again, I can see here the pins are aligned. There we go. Are these the inverted controls? There we go. So that looks like it's aligned to me. So I'll put some more pressure down. There is something stopping that going down. I think one of the pins might be a little bit bent. So if I put it down from a slightly different direction. Put it in a slight angle like that. That seems to be connecting. Let's double check that. A little bit further up than I would like, but they seem to be fairly uniform. As long as they're connecting, that should be fine. It may be that the screws or the bolts on the screws are a little bit higher than I wanted. Yeah, I think they might be. Right. Does seem to be biting down there. I'll turn it on, and if it doesn't work, then I can just take off those stands and maybe put some shorter ones in there. But this won't be a problem in the very final version. The reason this is happening right now is because I need some M2.5 threads. I can disable this now. I need M2.5 threads, but I've only got M2 or M3 threads. So if I get some nice long screws, M2.5, these will actually screw straight into the stand. And that's how it will be held. That's how it's supposed to work. It's just that I lack that right now. I'm glad I watched your 2 videos on this now. You're on live. Perfect. Great. I'm glad you're enjoying it. Yeah. So these wires now will go to the buckboard. As I say, I'm working backwards through this. So I'm actually going to remove this screen again. This was just a quick test fit. There we go. That worked well. That held the board in place, so now I can remove things. I can actually raise this a little bit on the pins, which will probably give us slightly better connection later on. Again, guys, the only reason this is happening right now is because I don't quite have the M2.5 volt bolts that I need. Let's bend this one in as well. Just make life a bit easier. So if I pull this up slightly, that should solve my problems, and it should still be a connection that I can work with. There we go. How much did all this hardware cost? Raspberry Pi was £28.50. This was 50p. This was £1. The display itself I purchased for 40. So under £100, round it off. Oh, and the battery, of course. So here's the battery cell as well. This was £7.50, and it just powers the whole thing. So probably about the price of an Amazon low-end tablet. So one of their Kindle 7s. Right, so let's start planning this now. This is the power input circuit. This goes in last. This is the DC to DC converter. So this is what brings the 3.7 up to 5 volts. I'm going to desolder this and put the wires on the other side. A reason being is it's designed to be flat to the surface. So I'm just going to put a little bit of pressure on the board, heat it up with the iron. Is that actually on? Soldering iron is heating up. It went into auto shutdown mode. That's why it's not melting. Right, let's get the helping hands out for this. Let's turn it this way. Oh, I'm actually twisting the metal there. Right, let's try that again properly, shall we? There we go. Twist it from the right part. That always helps. And now all I've got to do is heat up this side and pull, hopefully. There we go. Is it up to temperature? Seems to be. That is one stubborn bit of solder. Come on. There we go. Come on. Let go of it. There we go. This one again. Come on, out you pop. Trying to do this so it comes out without burning the the housing of the circuit itself is proving more challenging than it should be. Right. Anyone who's good at soldering is probably cringing right now. Wow, this doesn't want to come out at all. Come on. 440, it's up to temperature. Let's try doing it alongside. It's probably not enough surface contact with the solder. Wow, that doesn't want to let go at all. Alright, let's see what's going on here. I can understand this one, because that one's kind of wrapped around the board a bit. So that needs trimming. So I expected that one to be difficult, which probably means it's going to be the easier one. Come on. Solder's reflowing. There we go. There we go. That's what I expected to happen. So why isn't the solder flowing on this one? It's almost like the solder isn't receiving the heat somehow. Right, I might actually try putting a bit of solder on that one, because maybe the heat isn't being conducted properly. So, where's my reel of solder? I had it just now. There we go. Right under my nose. Yeah, I'm being unobservant again. Let's pull this off. There we go. I'm going to add a bit of solder here. Seems counterintuitive, but I don't think the heat is dissipating through the board enough to melt the solder that's gone into the hole that's actually holding it. So with any luck, this will do the trick. Put a bit more on there. Yeah, that's just rolling off. Yeah, it's like there's something on the surface that's causing this. Let's see if I can burn that off. There we go. Right, so there wasn't quite enough solder on the top to conduct the heat, and that's why I was having so much problem. So, yeah, there we go. That's now off. So let's flip this around. So we got negative on these sides, so let's put two green wires on this side. I don't have any classic red or black at the moment, and I've run out of money for the month to buy any more, so I associate green with ground because that's how house wires do it. You get the green and yellow striped ground circuit, so that's why I've decided to go with green for this. And the blue is just, you know, a different colour, so let's rinse this off. Let's fill it in. And right, so I want to go this way up. So let's do the same I did before, which is a bit more solder on this side. Right, that's out. I want negative on both sides. Come on. So now if I melt this, probably poke this through. There we go. So that's now tinned and soldered all at the same time. And I can just trim off the excess. And I'll do the same on this side. Now this is DC to DC, so this is going into, actually this is going into the Raspberry Pi. So I actually need to connect the Raspberry Pi wires to this one because it's out. So let's do that. And where's my Raspberry Pi board? Where did I put that 2 seconds ago? There we go. So this is the wire I should actually be connecting to it. So I'm going to twist that around. And I'm going to poke these through that hole there. Like so. Let's actually put it on camera so you can see what I'm doing. So I'm just poking the two wires out here. And I've just got to solder these. Same procedure as before. Twist this around so it's a bit easier to go in. That's now straight through. There we go. I don't want too much excess wire, but I don't want too little either. Right. That's another reason I glued this down, is so when I'm soldering and putting it around, it doesn't come free too easily. I meant glued the wire down, sorry. So same procedure, a little bit of solder on one side to help conduction of heat. And then I should just be able to poke the wire through, which will both tin it and solder it at the same time. I need to twist that one around a little bit. Twist the wire, make it go through. Heat up the solder. No, that's gone strandy. Need to twist that a bit more. If it continues going strandy, you know what? Actually, I'll tin it. That'll stop that from happening. There we go. Let that run down the wire. And we'll try pushing it through again. I may not have quite enough slack here. Let's try taking that off. There we go, that's in. So now I've just got to push it down further. I've probably got too much solder here now, so let's flick a bit of that off. Or actually I can just do it like this. There we go. And I'll just chop the excess off. There we go. Okay, so that now fits in there with very little excess in wire, at least as little as I can manage. Just like that. So now what I've got to do is pass some other wires from this side. Right, let's double check. So that's positive, that's negative, that's fine. Always check things 3 times. I'm curious what you use, because is this for device? This is my handheld Raspberry Pi device. You can make a case from wood too. I can't because I don't have the woodworking equipment. I've only got a 3D printer. But you could make a case from wood if you wanted. So I just need some wires on this side now. Don't need them too long because they will go into the charging board. You asked me what I'm going to use it for. Anything I can use a Raspberry Pi for. I can program a Raspberry Pi Pico, I can write code on it, read emails, browse the internet, watch videos. It's literally a little Linux PC. The only thing that's a little bit limiting is it's only got 512 meg of RAM. But you'll be surprised what you can do with that. I can run it as a development server. It's got Wi-Fi in. There's all sorts of things I can do with it. There is hybrid PLA, but in my experience it tends to clog nozzles. So I try to avoid that for now. It's possible it's my misunderstanding of it that's causing the problems. But it has caused me problems. This is negative. Yes. So let's go in here. You could tell I don't solder too often. There we go. Oh, I got that through then. That's so annoying. There we go. Yeah. I've only got a 0.4 nozzle here, and I don't really have £30 to spend on one for my current printer. Let's trim this down. I need to be aware actually of how deep these pins are. That's my other print job finished. I'll be showing that towards the end of this. Thank you for the roses, I appreciate it. Right, so I need some blue wire now. Where's my blue reel gone? There it is. I'm great at seeing things not in front of me right now. So measure out some wire here. Just stripping this down. I always twist it so it pokes through a bit easier. Same on the other side. There we go. A little bit. No, actually, there's enough solder there. That's fine. I'll trim this down. There we go. So that is now going to go in this recess here, and the wires will then hook back into the system. So I'm going to poke the wires through first, like so. And then this board will go directly in. So that way, I still have the ability to adjust the voltage if I really, really need to. And I can pull it out if I really need to as well. Where's my tweezers? There's my tweezers. There we go. So that will then go into my voltage. So that's going to be this board now. So these will be the external leads, so I need to desolder these ones. Let's put this over here for a moment. These are nice long wires, so with any luck I could just use the tension method. There's plenty of solder on them, so they should come through properly. There we go. And the only reason I'm doing this is because the board sits flat, and I want it to sit flat. I don't want the wires on the underside, as I originally soldered it. Will you ever be able to get Raspberry Pi or 4 in the US again? Probably. 2013 is going to be the recovery year, so you'll probably see stock in the first quarter or the second quarter of this year. Not sure how much stock there will be, but there should be some. I will be very excited when they start producing Raspberry Pi 2Ws again. There we go. That's how my soldering usually goes. Right, so this is plus minus. So this is going to be the one for negative. Yeah, let's try helping hands. See if I can see if that wire's long enough. Nah. Okay, let's just try eyeballing it. Right, so actually I need to go in this way. So what I could actually do is just do it across the top. That'd probably make a bit more sense. So if I put me a bit more solder on that. This, my friends, is what's known as making it up as you go along. It's my favourite pastime in the entire world. There we go. So that will now the thing with soldering is you really need 3 hands. All these other soldiers looking at this video going, what is he doing? And the answer is, I don't know myself. There we go, that's what I wanted. I'm going to angle that a bit further though, because I don't want it pointing towards the battery connector. Let's try that same procedure again, which is an angle that's pointing away. There we go. I'm also going to add a bit of glue to that, I think, to help insulate it from my bad soldering. Right, so that's out, so that's negative. And that's out as well. Trim this one down a little bit. Actually, I'm going to tin it first. I guess you could start on a Raspberry Pi Pico for fun. I have loads of Raspberry Pi Picos. I own 8 of the things. And they all do different little purposes. I even run one as a mini web server. Let's tin that. This will be another surface mount job. Again, same as before, I'm going to have it trying to point it out. That's a bit too long, I thought it would be. Let's trim that back a bit. And let's try and surface mount this again. Just weigh that down. Need a bit more solder on that. There we go. Nearly. Keeps going away just the last moment. I'm burning my my pliers now. Sure, breathing in rubber fumes is healthy. Not quite taking. Let's try again. This wire is a bit short for this. Let's try and bring it a bit closer. Because the green wire is a little bit longer, it keeps pushing away the circuit board. And that's what's causing me trouble. Also, I'm mildly incompetent. Right, let's try the helping hands. Keeps moving. That's half my problem. Right, that will definitely help. Can I actually reach it? Yes, I can. Right, now we might actually pretend to be somewhat competent at this. I'm going to need to twist it a little bit that way. That's now melted. Hold it there long enough. Solidify. Thank you. Yay! Right, that's now on. And it's not overlapping B, so that's good. Right, so I need a couple of wires now for battery. So basically, this is a reason I was trying to make even the leads that small, is because I need to poke them through. What I may do actually is twist this. Okay, that's a bit easier. Yep, there we go. So that's in there. Now I'm going to grab my 3D print. I'll be back in 1 second. You're soldering fine. We all solder like that. Good. I'm sure there's professional micro solderers shaking their head going, what is he doing? But they get paid and I don't. Right. So I've got another 3D print here. This is the latest addition to the whole project. And let's turn my camera back on. There we go. You never soldered? It's fun, you should try. Just don't touch the hot end. There we go. You can also build this with crocodile clips. You don't actually have to solder. It's just that it doesn't really occur to me to do it any other way, to be honest. It just seems obvious. Take away the support. So I don't know if I've sized these correctly yet, but the idea is that this sits on top of here, like so. Right. I may have made a tactical mistake with the wires already. Let's see how it goes inside. If I pull that there through and then slide this under, oh, this might actually work. That wire's a bit in the way. So this is basically a toolless thing I made that should, in theory, hold the board in place. So if I hold that down there and insert it, there we go. So now, when pressure is applied from the top, that will hold this. So when you're poking around with the connector, It may slide a bit, so a little bit of hot glue there to hold it in place. It's a little bit higher than I wanted, but that's okay. Actually, no, that's in line with the display, so let's see if this actually fits with the display, because it may overhang a bit too much, in which case I'll need to make this part shorter. So where's my display? There it is, it's right in front of me. Theme of today, where is the thing that's right in front of you, Daniel? Yeah, that's a little bit short. Okay, so I can also I could just cheat. Nah, I won't do that. I'll print one that's a bit shorter. So that needs to be about 5mm shorter. That's okay. But that basic test fit looks okay. It literally just slots in there, holds a power board, a little bit of glue, and it will hold this. But it also provides enough airspace. You know what? I'm going to show my other camera so you can see what I'm talking about a bit more easily. So let's turn this on. So you can see here that this is the cover. All it does is hold the charger board inside like that. So there's your charger board. It just fits inside. Let's see distance of this. So it just fits inside this little frame. It's got plenty of hollow space here because this chip in particular gets very hot when it's charging ICs from 0. So I wanted plenty of space above it so it wouldn't melt plastic or cause any other problems. This board then just fits neatly in there, just like that. And then we just pop it down. You can't see it because my thing's in the way. Let's disable that. Then we just pop it down into this recess, glue it in place, or I could add a tab and some bolts in the future, and then this will hold it without coming into contact with anything and without relying on hot glue. Then I have this second device, which I'm also going to test now. We take our 18650 cell, we pop it in like that, and then this sits on top and holds everything in place. So when I put this on the top, everything's held in place by pressure. Thank you for sharing the live, I really appreciate it. So yeah, these pieces basically hold everything in place. And I've left a little bit of a gap. Now what I may discover is I need to put a square hole through here so cables can lie and run through. We'll see how that goes in a moment. But yeah, the only flaw of this is that this is about 5mm too long. If I bring it inwards, then it will have plenty of clearance. But the great thing is it fits that board. I didn't measure any of this. I just grabbed a grab CAD model and I designed around it. And as happens 90% of the time, it comes out fine. Yeah. I may lower this by 1mm as well. And I will do that actually quickly in my Fusion 360. Let's see if my display capture works. So display capture. Actually, no, I want the Fusion 360 capture. Does that still work? Select game. Come on, update. Update for me. Not available. We'll just do a full screen capture then. So display capture and is that working? Ah, there we go. So that's fine. So we just minimize that. And you can see quickly what I'm going to do. So in Fusion 360, all I'm going to do is the body I need is going to be this body here, and what I need to do is bring in this by about 5 millimeters. So I'm going to grab that. I'm going to move this in. 2, 3, 4, 5. 1 for luck. And grab this and this, drag these in as well. And that should be fine. I'm going to drag this down by 1 mil. And these down by 1 mil. And everything else fitted fine, so I don't need to adjust anything else on this. I just need to get it printed. So save that and export. And power cap. Save that. Wait for that to convert. And I'm going to disable my personal camera for a moment. I need to go and reset my printer while that's converting. Where did I just put the board for this? There it is. Off and on again. I do find my printer likes to be turned on and off between prints, otherwise it has a little bit of a weird network error sometimes. Right, so that's now been converted. That's the printer's happy little "you need me" tune. We'll get rid of this one, don't need this one. Start again on that one, don't need that one. And we need to double click on, well, let's get rid of all those. I don't need all those windows open. Let's just open it in Explorer again. And double click. This will then bring it into my slicing software, and I can be printing this while I'm assembling everything else. With any luck, before the end of the live, I will be able to insert it. So last time, what orientation did I have it in? I can't remember. I think I had it like this. Yes. So auto supports. Auto supports. Back. Start slicing. This needs to be 230 because it's quite cold in this room right now. Raft, yes. And everything else just normal. Don't need to change anything else yet. Slice that one. Let's see how long that will take. 26 minutes. That's not bad at all, especially when it's with a raft. So print. Print. Power cap V16, that's fine. It should now stream over. Yeah, I can hear it coming to life. And I can actually view webcam if I want to. So I can actually see the whole test bed working. Got a little light there so you can see exactly what's going on there. You can see the print head come down. And we'll revisit that one in a moment. So now if I go off my display, So display capture, disable, back on my main camera. There we go. So thank you for sharing my live. Everyone share the live if you can. I will be posting this full live on my YouTube channel. So anyone who misses the beginning can go back and watch things. All right, so I don't need this one. But I call that a success. If it wasn't for this being a little bit too long, I would have got it right the first time. But for 26 minutes print, who cares? It's not that bad at all, is it? Right, oh, my personal camera's off as well. Let's turn that back on. And for now, that can just sit here like that. So now I've got to run the wires from here through the batteries. So this is... I'm sure this is a positive anode, but triple check everything. Don't assume you remember correctly, because I have. You do not want to get this the wrong way round. So RS Pro 18650. I typed in TS Pro. Actually, I've got the card right there. Did it tell me on the card? Do not insert with plus and minus reversed. So it's very, very definite. Again, I'm very, very sure this is positive. But it doesn't actually say on the battery, probably because they assume no one's so stupid they can't remember. I think I do remember, but again, I'm just double checking. So, RS Pro. There's the page on my phone. Accept all. Doesn't actually say. You would think for a battery pack that you absolutely do not want reversed, they would stick a negative and a positive sign on it. I have actually wired this up before, and I'm very sure that I got it the right way around. Otherwise, it would have exploded. N65. Which side is... Don't auto-correct me to size. I typed in side for a reason. Right, which side is positive? There we go. Yep, so, yep, the bump is positive, so it's just like a double A, and the flat side is negative. Right, there we go. Anyway, that's how paranoid I get. Just because I think I remember something doesn't mean I won't double, triple, quadruple check it. Yes, you know what? That is a very good idea. I'm going to triple check it, as I say I do, by using my voltmeter. That would have been a very quick solution, which I did not think of. So this should be positive, and then that should be negative. 4.4 volts, there we go. Yeah, that was positive, it wasn't negative, so that's good. That would have been the easiest way, but now we've checked in 3 different ways, thanks to my paranoia. So, right, I'm going to grab this wire. Thank you for the suggestion. Wouldn't have ventilated 6. I'm sure there's plenty of air movement in this. I haven't got something that covers the entire battery. And if it explodes, I will send you a TikTok video from the hospital saying don't do this. But I have actually charged this from low to full, and it didn't get that hot, so I'm not that massively worried. What I should really do is get some copper inserts, size this properly, and then pressure fit it. But I don't have any copper inserts, so I can't do that. Right, I want to get some solder on this end. Hold the wire in here. I was about to put the... there we go. Tin that so I don't do it too... I want to minimise the amount of time I heat up this battery. It's already got some solder on there, so it should just be a quick plop, melt, leave job. Yeah. That's on there, that's all I needed. And then the blue one. So again, I chose green because in my apprenticeship when I was doing electrical house wires, ground is striped green and yellow, so I've always associated green with ground, so I know I won't get those colours mixed up. Yeah, you can, you shouldn't. I don't have an alternative right now. It's probably safer just to use some copper contacts. So do as I say, don't do as I do, as my beloved father used to say. And when you think about it, there's a problem with that example because you're really teaching people to say that. But the point is, it's my risk to take. No one else will be using this device. So if it does explode in my face, it's only me this is going to hurt. So let's tin that side. My Wi-Fi cut out right as you started replying to me. Sorry about that. I think it's fine. I've tested this battery. I've charged it from zero to nothing, from zero to full. It didn't get that hot. It's not a completely sealed environment. It's a very loose-fitting lid. There's plenty of airflow in there. Some vents might be a good idea in the future, but I don't think it's going to get up to such a temperature that it's going to be a problem. It is contained, so if it melts or explodes or whatever, it should just be contained in here. I'm not saying it's the best design. If you feel that something isn't right and you come to design your own, then just don't do what I do. Think for yourself. Don't just monkey see, monkey do. But I assure you, if I ever get an explosion with this and I end up in hospital, I will send you all a TikTok saying, don't do this. Or at least my last dying words to my wife will be, send a TikTok saying, don't do this. And she'll be very confused because she doesn't know what I'm talking about half the time anyway. Oh, they make an actual ventilated version. Okay, okay. This is the cheapest one I could find. Basically, that's how I do most of my electronics. Is what's the cheapest one I can find. There probably are better ways of doing it, but I don't do it. I think half the fun is buying a cheap Chinese knockoff and discovering It popped, it exploded. It makes a much more interesting video than this worked perfectly. There we go. There we go, that's on that. Plonk that in, that fits. Test the purple pressure fitter, that works nicely. And it will slide around a bit, but that's okay. Put inside the roll while soldering. What? I burnt my house down for TikTok. Yeah, don't do that. Right, so I'm actually going to cut this wire in half. The reason being, actually I'm going to measure this down here first, and does it actually fit? 1 second, because that needs to run down here and into the board here. Yeah, there's plenty of room there. And I'm not going to do it this time round, but I will be modifying this with a switch on this wire. The reason being, as this is permanently connected to the boards, if you just leave it, it's possible that this circuit will end up draining the board. It shouldn't do. The specifications say it doesn't do it. But by having a toggle switch up here, if I want to leave it for long-term storage, I have the ability to physically separate that connection. And that is what I shall be doing in the future. So I need to make sure there's actually enough here. It's a bit short for that, actually. That's fine. I can just solder another bit of extended wire onto it. So I'm actually going to leave a bit of slack here. And for now, I shall use the twist switch approach, which basically pokes it through the hole here, and then I twist the wires together. So it means I can break it if I need to, and I can come back later and I can upgrade it with a toggle switch. The only reason I'm not doing that now is because I've got a bunch on order and they're late and they're not working. They're not arriving on time from Amazon as I hoped they would. So I will extend this wire out. This will basically poke through there. Another one will poke through there, twist them together, and that's my temporary switch. Because I'm professional, you know. Everything about me says consummate professional. It's not like watching Jeremy Clarkson invent a new type of car at all. There we go. So that's now twisty. So I need to put this on the positive side. And I'm just going to surface mount this again. Trim this back a bit. Let's tin it a little bit. So there we go, that's tinned. Right, so that's positive battery side. So let's get that down there, get this here, and hopefully a quick blast of heat will get that on there. I love it when it goes smoothly. That was so easy. The next one will probably be a nightmare now. Right, so I'm going to cut off another piece of... oh, I've actually got a piece cut off. Now, that will go through there and it will feed through here. So that's long enough. That's good. It's already tinned as well. So I'll just strip this out. That will then poke out through here. So I've just got to get this end on there. That is B negative. I need to put some solder on that so it takes more easily. Thank you for the follow. I really appreciate all my followers. And this end here. That seems to be on. Let's have a look at it through the magical zoom camera. Nothing is touching. Nothing is touching. Got a little bit long on that one there, which I don't like. I may actually put a bit of glue on that just to make sure they never actually touch each other. So I'll grab my glue gun. There we go. So yeah, there's no chance of them touching each other because I don't want to create a short in this. No chance of them touching each other. Good, that's what I want. And disable little zoom camera thingy. There we go. So that is now almost a professional job. I would never go so far as to call myself a professional, but nearly is good enough for me. So that will now route through here. Could twist that wire a bit. I'll probably do some little cable ties actually. I should buy some little cable ties. So that's now all soldered together. In theory, this should now, once I attach these two bits, be a working Raspberry Pi system. So let's test that with my HDMI rather than my display, because that might introduce a new level of problems. Where's my HDMI connector? There's the box, there's the cable. Also gets checked the external port. Does this fit? Oh, actually that's a bit tight. think it's in there. Do I actually have external from this? I may have made the casing a bit too thick. Right. Let's see if I can get power out of the battery. So I'm not seeing it come to life. So that is soldered on there. That is negative. That is negative. That is positive out. So that should be fine. Oh, yeah, I saw a flash then when it came on. Okay, there we go. So there's the Raspberry Pi starting. And where's my... Oh, that's come to life. Yep, the Raspberry Pi is booting. It's now booting off battery power. The flickering screen, don't worry about that. That's my Miracast box. I've had some problems with that before. But yeah, it's just booted up into Raspberry and that quickly. So that's good. That's working. Consider me shocked. I was massively expecting something to go wrong, but it's actually working the way I intended. Well, how often does that happen? It must be my lucky year. So yeah, I just got to get that little 3D part printed then, get the display on there, and I'm pretty much good to go. Well, I'm chuffed about that. So let's just break it by separating these wires. Now, as you can see, well, you can't see because the image will just freeze. But now the display is off, the whole board is powered down. So that connector works. So what I've got to do now is wait for this other little 3D part to print. So let's see how my 3D printer is doing. And it is 75% of the way. So I'm going to go use the little boy's room for 5 minutes, and then I will be back, and hopefully the printer will be finished. So 1 second. Thank you for the nice job. I will be back in just a couple of minutes, guys. Back, and there's about 2 minutes left on my 3D print. So I'm just waiting for that to finish. If anyone has any questions to ask me in the meantime, now is a fantastic time to start picking my brain about things, or even mocking me publicly. It's all engagement, so I don't mind. So we got the Raspberry Pi 3 here. We got the little battery holder here, which will be pressure mounted. I could actually put a little bit of hot glue in there. I could also Dremel through the side, put a rod through there. So there's a number of ways I can fasten that battery, but to be honest, this case is just going to come down flush and it will be holding the battery in that way. Who's mocking you? No one's mocking me, but I mock myself. It saves time and effort. That way, I've said everything to myself that any troll ever can, and I never need to get upset. That is my weird philosophy on life. Make fun of yourself before anyone else can. That way, you don't care anymore. Thank you for the likes. I appreciate it. In fact, I had a lovely comment from someone earlier on the video relating to this one, actually, and he was basically saying, you know nothing about technology, you don't know what you're talking about, all your videos are very basic. And I just laughed at him because he's like, Do you really have the time to sit there and put this hate into comments, especially when your entire video channel is empty and you've made nothing yourself? You could be the greatest expert in the world, but it doesn't matter if you don't share it. So, and what's the other thing? I had this argument with someone before, and someone actually pointed out he calls himself the computer knowledge enthusiast, not the computer knowledge expert. So he doesn't actually have to know anything. And I've always remembered that one. That was a really good one. Thank you for the follows. So it's all good fun. I enjoy the trolls as much as I enjoy getting praise, because it's all part of the human condition at the end of the day. It's not worth getting upset about. So yeah, I mean, this project is going remarkably well so far. I have just completely jinxed it by saying that. I guarantee this is where things will go sideways and nothing will work going forward. You'll probably see magic smoke coming from the board and all sorts of things. I'm glad you enjoy my content, and again, I really appreciate anyone who takes the time to follow me, anyone who watches my videos and sends praise and likes, or even argues with me. Every time someone interacts with my content, they're helping to push it with the algorithm, and that's a really good thing. Right, it sounds like my print is done. How will it work? I know how the USB is going to work, because it's not covered. I have a nice big hole down there, and I have test fitted a few leads in there, and it's got just enough room to get the USB in there. Now, it's not something I plan to use very often, because this is a touchscreen interface. So my theory is that I will mostly be doing touchscreen work with this. I may also, it's also got onboard Bluetooth, so I can pair a Bluetooth keyboard and mouse as well as an optional extra. And of course, if I the only reason I wanted this to be free is because I want to program my Raspberry Pis on it. So I want to get my Raspberry Pi Picos, plug it in there, upload some code. That way, when I'm out and about and I want to change the purpose of a Raspberry Pi, I've got a portable device that does that. So this is really a very fancy EEPROM programmer. That's my long-term vision for it. The other thing I plan to do is make a Star Trek tricorder. I have around 10 sensor boards. I want to see how much I can load this on with via SPI and start taking environmental sensor readings just like a character of Star Trek, because I'm that much of a geek. But that's why I've got so many holes and things in there, is because I want this to be expandable, changeable, updatable according to my random whims. Amazon has a handheld Bluetooth keyboard touchpad that is foldable and amazing. I have seen them and I adore the things. Right, I'm just going to grab my 3D print because it's finished. And we'll see if my second revision has solved the problem I had in the first place. And here we go. Here is my 3D print. You'll notice that I'm going for a nice, colourful handheld this time round. I got bored of the boring black slabs of glass, and now I just want something that's a little bit more cheery. Let's see if this actually comes away without breaking. Oh, bending a little bit. Now I should probably get a knife and slide it under, but no, I think it'll be alright. Yeah, that's coming away. There we go. Now I'll just put off these supports. Amazon has a hand... Yeah. I just read that one. Every so often it bounces everything up and down, and it's like, is that a new one? No, it's not a new one. Right, so let's flatten that a little bit. Where's my little knife? No, not where I thought it was. Never mind then. I'll just use these. It's taking a little bit of excess material off the bottom. There's not much actually. I think that's fine. So now let's see if version 2 of this works. So in theory, it should pop up. That's right, it needs to go in this way. So it goes in that way, through, and then under the board, and clips in place like that. And there we go. That is now the little holder. This then goes in place, and that is now completely flush with the top. That is perfect. There is no movement on that whatsoever. It's holding my board quite nicely. Wire going through there may be a bit of a problem, but I can always add another entry point in there, which is fine. For this version, I could even just do this. I'll just melt this wall down a bit. And let the wires pass through that way. That'll do. That saves me 6.5 hours worth of printing. I'm going to put a tiny bit of glue. Whoops a daisy. Here. Or does that turn itself off? Ah, glue's melted out this one. Let's pull that out. Just fixing my glue gun because it's poured backwards into the joint, unfortunately. So I'm just going to pull out the melted bit. It's got into there a little bit. That's fine. That's easy to pull out. And there we go. We get rid of that excess. Put the stick in the other way around. There we go. Now I'll hold that down. A little bit of glue there. Is that actually going in? Yes. There we go. A little bit of glue there. Nope, it's not holding anymore. I need another stick. Of course, I've got a whole bag of them. Do you think I can find them when I need them? Probably not. Oh, well, that's not the end of the world. No, I think it's the end of the glue stick is getting stuck in that. See if I can get this one going. There we go. That's all I need, just a little bit. Hold that in place, smear that around. There we go. That'll be pressure fit anyway, so I don't actually have to do that. That's fine. So this then needs to come around as well. You could get 2 USB extensions, add a port cutout. Yeah, I could. I could absolutely extend the USB from here. That wouldn't be a problem. Let's disable this. Never give me a glue gun, it always ends in mess. Right, let's put that there. Let it cool down. That's it, I've just got to get the display on here now. So that needs to go down there, through here. You see, the wiring is the bit I'm kind of figuring out now. That works okay. That one's not so critical. And the only problem is, will it, because it was originally designed to go through there. What I should probably do is make this, cut this bit off here. That way you can just route the way that I intended in the first place. But that's a small alteration. I'm not going to wait another 23 minutes for that. So let's go try and get the display on here. That's the next task. As I say, the final version of this will be a bit easier to assemble because it's supposed to be assembled as one board, dropped in there, and then some 2.5mm screws go up through these joints here and screws into the stands. But because I don't have any 2.5M or M2.5 threads, I can't do it that way. So I'm kind of hacking this a little bit from the way I've actually designed it. Because again, it's going to be another week until those screws arrive for some reason. So that's why this is going a little bit less, is a little bit clunky right now. Let's move that over there into the indentation I made. Right, so I'm going to get my little camera and have a look inside. See if it's all lined up properly. They look like they're on the teeth. I extended that one on purpose. So maybe I just need a bit of push. Might need to go a bit of an angle actually, because there's some slightly bent pins on this side. Right, something's preventing that from going down. Let's move this over here so you can actually see what I'm doing. I'll take this out for now. Don't need that in there. Okay, so it was actually connecting to something. There's a screw on this side. I think the thread's gone in there. Right, that's better. Something wasn't quite even on it. Camera in there again. Looks like it's aligned. I don't want to put too much pressure on it. There's probably a use too much pressure job, to be honest. Okay, there's definitely something blocking the way there. Maybe it's more slack on the wire I need. Disable this for now. Yeah, it might well be. Something's catching on it. I'm trying to be gentle, yet firm. The other thing I can try and do is pull this one off. Let's see if I can get it on that way. There we go. There may be a slight bend in the pins that's causing the issue. Yeah, there's a slight bend there. So let's see if it works this way. Yeah, I've got to put this in at a slight angle. That's why. And combined with the threads going on top of the screws, I think that's what was causing me the issues. So let's see if I can do it this way now. Let's get the camera back in there. Yeah, I might do. Big thing is to get that aligned. There we go, now it's on there. Now I need to get that screw on there. Ah, there's a screw on this side is the problem. Right, so because this thread is longer than the rest, that's interfering. So I'm going to I'm going to pull that down with the screwdriver. And then I'll screw it back afterwards. Pull that down a bit. I really need those 2.5mm screws. That's half of what's knocking me down right now. Oh, that feels better. Did that go in properly? Feels a bit lopsided. So we'll look inside again. No, that's not going down with the teeth quite right. Perhaps I should have done this live when I had the 3 and the 2.5. Okay, so is there something on this side? Yeah, it's that little screw again. Same thing. It's just preventing it from going down at an angle. Let's get that over there, get that over there. If you want to get it on one side, it's okay. You know what, I'm just going to get rid of that screw altogether. 3 in there's fine for now. Let's see if that makes any difference. Right, so what's that one hitting? Right, it's hitting the edge of the case. I'll push that in. There we go. So what's that? Oh, that's catching on the end there. So, but I keep forgetting that battery. There's something on this side. So what's on that corner now? Let's disable this. That feels better. That feels like it's on. Oh no, there's quite a lot of gap in those teeth. So there's something preventing it from sitting properly. Maybe it's just the bolts on everything. Let's move that away from there. That's fine. Now, is it far enough on the teeth? What I can do, let's just leave that out because I keep dropping the battery out. Well, actually, that feels quite firmly on there. It's too lifted on one side. So what's on that one side? It's not coming in contact with the battery charger. That's fine. So again, it must be that bolt. So maybe if I remove that one as well. It'll be so much easier when I get the proper threads. I thought, you can work around it, Dan. It'll be fine. You won't have any problems. I've got to get that other little screw out before I try again. There we go. Remove all the loose bits of metal. Let's see if it sits on here now. There we go. Okay, so it was that screw in that particular corner that was causing the issue. Ooh. Right, that's now on there. And yeah, that should be fine. And we'll disable this one. That one. There we go. The standoffs were a little bit tight. They were adding a bit too much friction there. I could have probably forced it on there if I put more power into it, but yeah, I wanted to avoid doing that. These will just lay across here for now. I may as well just lay across here, to be honest. That'll work. Let's twist this. Nice. Well, ask me questions. If I have time, I'll answer them. If I know them, I'll answer them. If I don't, I will say, well. You know what, I could just say, for now, I'm just going to twist these together. I'm not going to poke them through the hole. This display light has come on. That's a good sign. I'm not going to worry about battery drainage or anything like that right now. Tomorrow I will have some toggle switches. I can solder those in properly. That's fine. This is assembly phase 1. Right, so I need to put this in here as well. That goes in there. And we'll put there we go, cables down there. And there we go. We have, and I'm going to turn on the other little camera because you get more detail from that one. So we have that USB port. A little bit rough on the plastic, nothing a knife won't. I added any kind of BMS to that device, or is the battery going to be replaceable? Not sure what BMS means, mate. We have the SPI connector here, so this is where the sensor boards will get plugged in. Plenty of space there. We got our HDMI lead there, and we've got our audio jack. In here we have access to the Type A. Battery management. I haven't added any battery management into this yet. I could take a chip, some LEDs, run them down the side. So what I might do is have some LEDs down here with a little battery toggle. But all I've got to do is make a circuit that measures between 4.15 and I think it's 3.2 it goes down to. And then just make LEDs respond in accordance to that. So that's probably what I'll add in the long run. So yeah, these ports are looking pretty decent. We seem to have access to everything. This is just a pressure fit case for now. Eventually I will add in some holes here and here, and it will be screwed down. But it's okay for a first prototype. Let's turn this one off. That's just distracting. There we go. There you go. There's the basic device running. Now, the reason you're not seeing anything on the display right now is because I haven't actually enabled the display in software. So that's the cost breakdown for build. It was £28.50 for the Raspberry Pi. I'm looking for a pen. I don't use pens very often. Let's just use a calculator. So calc. Let's do a rough cost analysis of this. So it was £28.50 for the Raspberry Pi. For the display, I picked mine up for £40. For the battery, it was £9.90 with VAT. For the upboard, the battery booster, that was 50p. And for the oh, I just screwed that one up, didn't I? And for the other board, that was £1. So £1.50. Right, £1.50. Add 28.50. Add £40 for the display. Add about £5 in printing materials. £75. So this cost about £75 in raw materials, which is about the price of your average Kindle 7. Thank you for the snowman. I really appreciate it. So yes, we got a battery in the side here. We've got the display there. It's now just a matter of software. So let's see if I can get the HDMI cable in there. Did it actually? Yes, it did power on. I did check that. Let's turn on the mirror box. Let's get this HDMI lead in there. Okay. It's not coming on the screen. Of course, to turn this off and on again, I need to go in there, open it up, and uncross those wires. Otherwise, it's in a permanent on state. So it really needs that toggle switch. Now, hopefully the toggle switch will arrive tomorrow, and I can do a quick update. But it's already a week late. So, yeah. I'm just putting this off again. As you see, it's just a pressure fit. There we go. So I got to uncross these two wires. Let's get the HDMI lead in there first and reboot the machine. Actually, let's see if I can get it in there a bit further. And we'll unplug this. Plug it back in again. There we go. So we've got the HDMI signal. So there's the Raspberry Pi. So I've just got to set up this display now to actually work from boot. Ignore the flickering. That's my capture box. It's not the computer itself. I think it does it as it's changing resolutions and things. So I need to get a mouse in there now. So this will be a good test of the. There we go. There you go. That easy to get a mouse in there. So you should now be able to see it. No, I'm not from Lancashire. I actually live in South Wales. But I was born in Canterbury. And yeah, you can see that the machine is working well. So if I remember correctly, what I need to edit is the config.txt. So terminal is probably best for that. So I'm going to unplug that, and I'm going to plug my keyboard in because I've only got one USB port. I do have actually a Type 2 USB hub, but I'm not sure where I'll put that right now. But I just swap between the two different peripherals because I'll be using display on this in the long run. Wattage is a bit low apparently, so I might need to adjust the voltage booster. So sudo apt update. Oh, actually, as soon as it settled down with the keyboard, the voltage error went away. Sudo apt install gedit, which is one of my favourites. Actually, no, I can just use genie. What am I doing? cd slash, whoops, cd slash. That's not DOS, is it? Right, just do this. That'll be easier. cd boot. Genie. Sudo, that's what I want. Because this is a system file. So sudo genie config.txt. So now I need to go to the end of this file, and I need to look up the command. So it's on the Pimoroni website, which I'll use on my mobile. So Pimoroni, if I can spell correctly, Pimoroni hyperpixel 4. Instructions directly on their website. It's one of the reasons I like using them. They tend to have everything documented quite nicely. And if I can find the document, that is. Standoffs, yeah. Oh, there's a one-time command I can run. Okay, let's just run that. Oh no, that's for legacy. Okay, that's fine. Right, there we go. So I just need to type in DT overlay DT overlay equals. My dialect is very much a mongrel because I've been living in Wales for so long. I doubt it's anything. Is that the right one? Once you've installed, you only need one line. Yes, KMS. I don't remember KMS in there. That's why I'm pausing. Hyperpixel 4. Save. Right. The rest is all rotation stuff. Don't need that. Right, so let's just reboot it. In theory, oh, the other thing I want to install is Matchbox. Sudo apt install Matchbox, which is a virtual keyboard. Yes. Otherwise, I'll have trouble typing things in. As you see, it's a pretty quick device. It likes these lower resolutions. If you pump it up to 1080p, it can slow down a little bit. But at 720p, this is 800 by 480. It flies. So that's good. And that's mostly down to a lack of video memory. If you increase the amount of video memory at the expense of system memory, you can speed up the graphics processing a bit. So sudo reboot. And let's see if it comes up with a display now. Might not be. Okay, so it's still defaulting to desktop. I'm going to try rebooting it without the HDMI plugged in. In fact, I'm just going to shut down the machine. Ungraceful shutdown. There we go. I'm going to unplug the HDMI. I'm going to see if it works now. Let's try again. There we go. Not the best way. Definitely need a real switch. Yes, this is Raspbian is Debian based. Should be responding by now. It's receiving power from the pins, so it should be okay. Probably, I'm sure it's just software. Okay, let's see if it's working on HDMI. Nope, HDMI has come on, probably needs another reboot. Has it got to be the worst way of starting a computer? Oh, it's not going up on my other display. That's better. Okay, so it's still working, that's good. Why is it not coming on my main monitor? Interesting. Oh, it's probably rebooting. I'm seeing different times and syncs, and I'm overthinking things. Sorry about the flashing, guys. I've tried Zorin before. I can't remember much about it, though. I think it was just a very light Linux. Let's try the legacy instructions. Let's try the curl command. Might actually be worth doing. What was the shortcut for terminal? I can't remember. I'll just plug my mouse back in. Oh, there it is. I did get it right. I'm just being too quick. Sudo apt update. And then I'll do an upgrade, because I don't think I've upgraded this version of Raspbian yet. I haven't done an OS update, so that's probably why I'm having some problems here. So sudo apt upgrade. This may help. Yes. Why did it just abort? Let's try that again. That's better. I must have hit a wrong key. Yeah, it may be that my kernel's out of date. I know Raspbian comes with the drivers for this display, but that doesn't necessarily mean it's in the unupdated card I downloaded. Should have worked, but maybe there's a patch I don't realise. It's possible the screen didn't connect well. I am seeing power go to the display, so I believe it should be connected. If not, what I can do is remove the stands and I will just pressure mount it. And I'll just have to wait for those M2.5 screws to turn up, which is why I'm having some problems right now. I promise you I did design this to go together quite well if you've got the right hardware. It's actually quite annoying that Raspbian went for 2.5M. I don't know anything apart from laptops that use 2.5M screws. So we're just conducting a Raspberry Pi update. As you can see, there's quite a lot to update, so it's obviously out of date. To see if these drivers will then enable. I have typed them into config.txt, which should have loaded the drivers for the display. So once this is done, I'll do a reboot and I'll see if that solves the problem. If it doesn't, I have a terminal command I can run as well, and hopefully that will bring the display to life. It's also possible there's a connection error here, so before I run that command I might try taking the stands off and just pushing it down on the connector properly. But hopefully this is just a small software issue because it's not updated. Oh, there we go. So it's adding a bunch of DT overlays there. Yeah, that might be it. Adding diversion, yeah. It's adding quite a lot of graphic stuff here. I should read through this. WM8960 sound card. What's that? Can you actually get a sound card for it? Or is that just the one that's built in there? So that's WM, what was that, 8? Nah. WM sound card. Yeah, WM 896. Oh, it's an audio hat from Waveshare. That looks interesting. It's for hi-fi playing. Supports stereo decoding and encoding. I didn't know that existed. Yes, hopefully everything was done because the stands make it nice and stable. When I get the stands flush with it, rather than on these little bolts and nuts I've got there, it will be much more in line with what I wanted. But there we go. There's the little audio hi-fi board. It's quite interesting. 61%. I swear I have spent most of my adult life staring at progress bars and percentage messages. Installing 1%, 2%, 5%, 95%. How did you jump that high so quickly? I've had that before. Oh, it's been on 62% for a while. Hopefully it will jump up quick now. Still installing. How many graphics overlays does this thing have? That's interesting. Is this system capable of doing some office work, scanning? Yeah, you do all that. Yeah, it'll run LibreOffice, no problems. You can add a scanner, assuming there's a driver for it. Hey person, how's it going? See what I mean? 62% for ages, now it's jumped up to 91% when I just looked away. Now it'll pause on 91%, then it'll jump up again. Oh, it's updating the high icon theme. That's essential. Thank you for the follow, I really appreciate it. Is it possible to install Windows LTSC, for example? Last I checked, it was not on the Raspberry Pi 4. You can install the IoT version, and there is Windows. Get Windows on Pi project, which works quite well, but I've never used the LSTC version with Raspbian, and so I can't comment. Right, so let's try rebooting and see if this works. I recently got a Raspberry Pi Pico, cool stuff I can do with it, cool projects. It came in a kit, nice. The kit will save you some time. Okay, so that's just going to HDMI again. I might try rebooting without the HDMI because it may be defaulting to HDMI. I don't think it's worked like that in the past, but that doesn't mean there wasn't an update. So we will get this display working eventually. It's either that or I've broken the display. That's always a possibility. Probably don't need the mirror box on right now. So mirrors are taking longer to boot. It seemed faster than before. Oh, of course, it's done a bunch of updates in that. Give it a moment while I feel mildly nervous. Of course, it's possible it's actually trying to go to this display right now and it's not on properly. So let's go with plan 2, remove the stands and see if that makes a difference. Because it is entirely possible that's the issue here. Let's get that up. Right, let's remove these stands now. Don't need the HDMI right now capture, so we'll disable that. And that's more of the level I expected it to be. So definitely those nuts and bolts are causing problems. So we'll just try turning this on now. Using the world's crudest switch, 2 wires twisted together. I can't wait for the actual switches to turn up. I'm going to give it 2 minutes. Alexa, start a timer for 2 minutes.
2 minutes, starting now.
The backlight is working. So it's definitely coming onto power. It's definitely settled down. I've tested this screen a few times before I started this live, so the screen should be working unless I've broken it since then. But there is definitely a light coming on. I'm giving it 2 minutes. It won't take that long to boot up, so if it hasn't come up in that time, then I'll try HDMI, then I'll try running the legacy command, see if that works. But if nothing else, we've seen that power is going to the board, so we know the battery circuits are working. It's just this final leg of getting the display working, to be honest. And then one more case revision after this, allowing for wires to go to more sensible places. And it's a finished design. So I can put that up online and people can print their own out if they want to. And I have to use the GPIO extender with this particular board because the SPI interface interferes with the HDMI port if I don't. Alexa, time remaining.
You have 30 seconds left on your 2-minute timer.
Basically, all I'll use my Alexa for is playing music and setting timers. It's basically my alarm clock. But it is nice to be able to play music in every room in the house. This is just Raspbian. Alexa, stop. All right, that's long enough. Let's get this HDMI lead back in there. Let's get this back on. Raspberry Pi is still working, and that's good. We'll try running the command. I may need to do a reinstall of the OS or something. That's all I think can happen. Don't worry about the flickering, and that's just my capture box. Actually, what I should check is that config.txt file didn't get overwritten, and I should probably check the spelling one more time. What was the keyboard combination for to launch terminal? I did it earlier. I can't remember what it is now. Terminal short cut. Key Raspberry. Yeah, Control Alt T. I thought I pressed that. Control Alt T. I unplugged the keyboard. Yeah, it's no wonder it's not working. Right, let's try it with the keyboard in now, shall we? That's better. Oh dear. I don't need display settings, I'm sure of that. If I just go into the boot folder, I will double check that the thing got saved. It's config.txt, yes. So there it is. There's a bunch of spaces after that. So that's DT overlay. Let's read and make sure it's right. It definitely did save, so that's good. PSA. So DT overlay, yes, equals VC4, yes, hyphen KMS, yes, hyphen DPI, yes, hyphen hyperpixel. I don't see any spelling errors there. If anyone else does, let me know. DT overlay, config. Don't need any DT param lines. Okay, let's try the one command line trick. There we go. So let's go back into this. I can exit this. That's a curl. Get pimoroni.com/hyperpixel 4 and pipe bash. Right. Does this need an interface? Remember, PSA install process change by users. Should read this. If you're sure you want to install the legacy drivers, use curl. Okay. Okay. Try the legacy. Get Pimaroni-legacy bash. May explode. That's fine. Whatever. I'll just go through this process. Right, so I just have a pi pixel there. So what I need is 3 plus A or older, so that's 2. Installing rectangular for pi or older, yes. There we go. Let's see if this works. I'm building a handheld Raspberry Pi. This is all happening off battery power, and I've built the battery circuit. I'm just trying to get this touchscreen working. Reboot take effect. Yes, that's fine. Ooh, ooh. Made my display different. Hey there, how's it going? What I may do is end up reflashing this SD card. Yes, actually, is SPI enabled. This is a DSPI, so I'm not sure if it's needed. The screen's gone black, so it's not loading on HDMI anymore. It's definitely firmly down there. Yeah, it should be a fairly straightforward process. I've done this before, so I've probably cocked it up somewhere. So I think what I'll do is I'll pull out the SD card and I'll reflash it. There we go. Pull out the SD card. Battery's disconnected. Unplug this. Let's just reflash it. So where's my little... that's right, I can just use this. And I'll put on my main display so you can see what I'm doing. Display capture. Show source. Okay, let's get rid of this for now. And the Raspberry Pi. Yes. Better turn off my soldering iron. Right. So in theory, all I should do is just grab this one, bullseye, storage, and write. Yes. Let's bring up my TikTok so I can still see what you guys are saying. Have I done much respect to trimming Pi startups? I tend to just use Diet Pi, or I use Raspberry Pi Lite if I want to improve the startup speed. Now I've hit the SPI issue before, but that was on my other one. This is DSPI, so I don't think that's an issue, but I might be wrong. Either way, I'm just going to start from scratch, which shouldn't take too long. That way I know I'm starting with a clean slate. I know this is the procedure I've used before. So what I'm also going to do is grab the instructions. So hyperpixel for Pymoroni. I'll just grab the command and paste it into the config file, and it should just boot then. I've done it that way before. And if not, it might be that I've screwed up the screen somehow. That's entirely possible. Hope not. I don't have another £50 to buy a screen. Yes, £54 now. I got it in a Black Friday deal, so I only spent 34. Yeah, £35 at the time. So let's find the instructions. Yeah. Go into the repository there. I don't want to rotate. There we go. Huh? Right. I think this is an old one, isn't it? What's going on here? I definitely saw different instructions earlier. So where am I pulling those from? That's the legacy. Right, that's all I need. Once installed, you only need one line in config. Are these the up-to-date instructions? I think they are. I have no idea, but it's just DSI. Or D, I think it's DSP, sorry, DSP. Their instructions are not 100% clear. Right, that's issue 177, that's fine. That was what they directed us to. PSA, make sure you disable I2C, SPI, and other interfaces. These can conflict with the device tree. So we've got to make sure these are disabled, not enabled. Fresh image is recommended. Make sure you also disable the Pixel 4 init system service. Raspberry Pi 3 users, latest greatest, forego installer. Use the instructions below. Okay, that's fine. So are there more instructions? Yeah, I'm pretty sure it's just the DT overlay I need. That's all I did before. So I'll just grab that. So just waiting for this to come down now. Ooh, final 5%. Yeah. Digital signal processing. Or as I like to call it, voodoo. But only because I really want to get my hands on an old Voodoo card and a 486 machine and relive original Tomb Raider as it was meant to be played. Actually, when I was doing it, I had a Power VR set up originally. And it turned out I made the smarter choice because Power VR is still around, and I don't think Voodoo are. That was the 3DFX company. I'm pretty sure Nvidia put them out of business. Whereas Power VR just went to mobile phones and games consoles. Okay. So, now in theory, I should just be able to go into my card. Where is it? Where's my boot? There we go. Now you're detecting it. Should come up with am I being dumb? Thank you for the heart. I really appreciate it. Huh. If this SD card's broken now. Right, so that flashed. Push that back in. Ah, there we go. So it's boot F. I'm probably just being blind. Right, so now if I go to config.txt and open that, then all I need to do is go to the end of the file and that command there, save. And in theory, that should be all I need to do to boot this up. So let's take this SD card out. Let's put it where it belongs. I'll disable my capture display because you don't need that anymore. There we go. We go back to my main desktop. We also don't need mirror box. In theory, this should just load. No, there was. I forgot to disable my my HDMI capture. That's why you're getting a black thing there, a black box in the display. Fortunately, this wire is in the way. Otherwise, I wouldn't have to do it this way. There we go, and it's in there. It's like a game of Operation, only it doesn't go beep. There we go. Right, let's straighten this wire out. Let's see if it works this time. Right, this may take a few moments because it's a fresh install. Yes, I 3D printed the housing. Yeah, I did put a lot of thought. I do have access to it. I just need to use a pair of tweezers. That's all. I don't intend to remove an SD card from it very often. But yeah, it is something that needs improvement. Now this is a little bit concerning because last time I did it using this method, it worked fine. So there's one of two possibilities. Either the instructions I'm using are wrong, and I don't think they should be, or I've buggered up the screen. I'm going to turn on my mirror box and I'm going to plug in my HDMI, see if I'm getting a signal out that way. Yeah, I just plugged the HDMI in. Power's definitely on. I could also try plugging it into power. I've been running off the battery for a while now. I wouldn't have thought it would be voltage, but this is one way of finding out. If nothing else, we can see that the voltage light is on, so that should... This is a 1.5 amp power supply, so it's designed to use with it. And I'm going to try rebooting this again. Of course, it's not going to reboot because I've got it on power now. That just disconnects the battery. It doesn't disconnect anything else. But at least it's swapped over to mains power without any issues. Okay, so we've got some live action on the HDMI. Lead is triggering the screen. There we go, there's a Raspberry Pi OS. Feed it some extra power just in case. Flickering is normal, that's just my doodah. Okay, so that's loaded up. Interesting, this display is just not triggering for some reason, but I don't think it should actually be allowing me to do this, if that makes any sense. And that's fine. All right, skip the that, skip this, and restart. Let's see if the restart. Oh, it did actually change. Oh, that's interesting. So it's now got a portrait style. So it's done something. No, it's definitely got enough ampage. I've already tested that. I've actually had this running off this battery circuit before. Yeah, I've tested all that. She's not picking it up for some reason. That's interesting. See, it does go to portrait mode, so the software mode is activated, but the screen isn't triggering. I wonder if there's a problem with the display. Because I've had this running many times before, and it's never done this. So anyway, let's unplug this. It's had a chance to reboot and run once. We'll see if that makes any difference. Thank you for the follow, I appreciate it. I wouldn't have thought so, because I've literally just installed the OS. I've inserted that line into the config.txt file, and it's always worked before. So unless there's been a very recent update on Raspberry and OS that has bricked it for some reason. I don't know. It is why I do a little bit of Googling. Because, yeah, that should have come up on this display by now. Absolutely. And I know I2C would not be enabled right now because it's a fresh install. I know SPI wouldn't be enabled, which is a fresh install. According to the instructions, those should not be enabled because those are the technologies it uses to run the screen. So unless that DT overlay, or I'm putting it in the wrong place. Right. Gist, boot, config, hyperpixel, Raspberry Pi 4. This is the 3, but that shouldn't matter. Let's have a look. Okay, so it is actually saying on this config file. Oh no, those are commented out, so that doesn't matter. Let's just go to the end. So there are some slightly different commands I could be using here. So we can try those. Okay. Oh, so there's just a DT overlay hyperpixel 4. Maybe I'm using outdated instructions. Let's hope that's the case. Because that will be a nice easy fix. So let's turn this off, get the SD card out, and I'll edit it on my PC. And we'll disable this, we don't need that right now. So disable the mirror box. Does the Raspberry Pi support Ubuntu? Yes, it does. It also supports Pop! OS. Okay. So all I'm doing now is editing the config.txt. And this time I'm just going to type in hyperpixel, which actually strikes a tone with me. So it might be their GitHub instructions which are confusing. Let's hope that's the case. Config.txt, there we go. And I think it was just DT hyperpixel. Save. Right, I'm going to read that document again. So that's all to do with rotation. That's not particularly valid. Okay, so I can type all that in later. Okay, so let's save that and let's try rebooting again. Can it run Minecraft Java? Probably. Probably quite slowly. Depends what you mean by run, really. Would a gentle, sedate walk work for you? Dropped it in there now. Come on out. There we go. Yeah, these power wires are getting in the way. I probably need to glue them further into the corner. That's half my problem right now. There we go. In you go. Right, let's hope I don't have to pull that out again. That or smaller fingers, yes. Cross your fingers. Cross your fingers. (1080p) at 30 FPS? Yeah, no chance. No chance at all. My go-to brand right now is eSun. All this is printed with eSun filament. Oh dear. Oh well, I knew something was going to go wrong. It's alive. Nothing can go perfectly in alive. That is literally the law of mankind. So at least we're not breaking tradition. Let's see if HDMI is working. I may have to call it here and go do some more research and some updates. I may even try it on my other Raspberry Pi, just in case something's wrong with this board. Yeah, so at least the Raspberry Pi HDMI is still working, so it's still a usable board. Yeah, that's got me stumped, that has. And getting colour to it, not colour, we're getting a backlight turn on. We're getting normal HDMI. Now, I have run these before. Failed to load overlay Hyperpixel 4. Okay, fair enough. So that's definitely not the right one. At least I got an error message that time. And I didn't get an error message on the first time. CD access sudo genie config.txt. No way to test the screen on another, but there is. I have one over here. That's probably what I should do. I'll try typing this in once more, because you know, repeating the same action again and again is definitely the way forward. Yeah, fully assembled. Tab repository, installing, uninstalling. A Hyperpixel 4 setup for Raspberry Pi 3, B Plus or earlier will not readily work if you move it over to Raspberry Pi 4. You should run the installer again. Okay, that's fine. Maybe it's because I'm using a Raspberry Pi 3. No, because I was definitely using... Yeah, I was using Raspberry Pi 0 before, so that's not relevant. And I was definitely using a Raspberry Pi 3 before because I've run it on this setup. So... Okay, that's the rotation. Don't care about rotation. Totally mad. I don't care about rotations. Just give me the simple, straightforward command. Thank you. I hate open source documentation. It's never just straightforward. Yeah, they shove it all under issue 177. They don't actually put it in the main documentation, which is pretty poor. Manual installation, rectangular. Okay. Let's try the math. One more thing, then I'm going to call it a day, I think. So, sudo. Oh, I've got to do a full upgrade again. No, I'm not going to do that. I know I've got this running without doing that. Apt install git. This is a touch Raspberry Pi. Right, it's already there. Git clone HTTPS. I'm going down rabbit holes here. I have a suspicion that there might be something wrong with the display. GitHub. It's going to require a bit more, maybe off live troubleshooting, and then a video describing how I fixed it, or maybe it'll just start fixing itself. Pymori/hyperpixel 4 hyphen B, and there is a Pi 3 edition here. Permission denied. Okay, is that because I didn't use a sudo? Nope, another permission denied. Did I not type that in right? Let's try again. Git clone. No, I'm trying to grab it from... well, yeah, actually, it will compile it itself if I can actually get the repository to work. https:// github.com/pymoroni/hyperpixel 4 B Pi 3. Oh, for heaven's sake, why are you giving me permission denied? Why are you putting instructions on a website if they don't work? Do you not test your own stuff? That is pretty disgusting. Okay. That's annoying me now. So the manual instructions do not work. Right, we'll try the curl thing again. This is my last attempt, and then I'm going to go away. Curl SSL https://get.pymoroni.com/ hyperpixel 4 and pipe bash. Could not resolve host. It's because I didn't do a sudo apt update. Is that what it is? I'm a complete dumbass. I didn't set up Wi-Fi, did I? Here I am, following instructions. I haven't even set up the Wi-Fi. Okay, and I like it when I'm the idiot. When I'm the idiot, I can live with that. I don't like it when other people are idiots. So, okay, that's fine. That's all down to me. That's my bad. Oh, okay. I would like it though if Linux would give you a message saying, "You idiot, you haven't set up Wi-Fi." Can I still do it through this? Probably. I'm going to try and do it through this because I don't have a mouse to work at the same time. I'm going to disable it so you can't see my login information. Let's let that one out. Right. Wireless LAN. Passphrase. Where's my phone? I need to get my data off there. I just wasted so much time being a moron. And for those of you going, why doesn't he know his Wi-Fi password? It's because I change it every month, and it's always a random string of characters and letters. There we go, there's Wi-Fi enabled. That's better. Can't believe I did that. It's because I publish videos like this, and I did once manage to put out a password that was written in Notepad behind it. So now, on the basis that I know I'm an idiot, I take extra precautions. Right, okay. Let's try those instructions I was swearing about earlier in a fresh light of actually having it work. Right, so manual installation. Let's do an update first to make sure it actually is working. Sudo apt update. Good. Good, that's fine. Right, I'm not going to run that one. I want this one. Fatal could not create work tree, permission denied. So it's still giving me a permission denied there. That's better. I need to run a sudo. Okay, that's fine. And cd hyperpixel 4, and then it's just a run the installer sudo /install.sh, and this is a manual installation for the Raspberry Pi 3 version, so I know I'm getting the right one. Before rebooting, use hyperpixel rotate right left normal to rotate your display. I don't need to do that. Right, so it's added in everything I could possibly need. Right, so it says the Hyperpixel 4 already exists in config, that's fine. It's added in everything else. It's copied over the DTBO. Right. This will either work or it won't, in which case it's beyond what I can probably solve in this live. Reboot. So cross your fingers. Hi, I'm Arrow, how's it going? And again, guys, just so you know, this has been running off the battery the entire time. I keep forgetting to plug it into the wall. So that's pretty impressive. Right, it's defaulting to HDMI again. I'm going to try rebooting it once more without the Wi-Fi, because it might be defaulting to first connection. So I'll disable that and I'll boot it up that way. This is my incredibly primitive switch. 2 wires twisted together because I haven't got any toggle switches right now. So I'm going to give that 2 minutes. If it doesn't load, that's it. That's as far as I can get. I need to go off troubleshoot, try it with other machines. And bit of a disappointing end to this live, but keep an eye on my TikTok video. I'm sure there'll be an update on it in future. Besides that, I've got to save up and buy a new screen. Let's hope not, eh? Alexa, start a timer for 2 minutes.
2 minutes. Starting now.
If it doesn't load up in 2 minutes, it's not gonna. So we are approaching the end of this live. I hope you've enjoyed the battery kit works. The battery works. It's powering the device. Everything works except the display coming on, which is very frustrating and very annoying. But at least everything else works the way it's supposed to. And when it's running on HDMI, it's not giving me any voltage errors, except for that one time where I plugged in a USB cable, but then it settled and went back to normal. So I'm glad I've inspired you to start tinkering with your own pies. It is good fun, even though it's frustrating. When you finally get it working, it's great. And this is the annoying thing, I've had this setup working before, not assembled. So this may be a case of disassemble it, check all the connections, see if there's something obvious there. I do have another board here to try it with. So maybe I've damaged the GPIO, but I'll try getting this screen working with a standard Raspberry Pi first. Doesn't look like this is working. It would have booted up by now, I'm pretty sure. So a little bit of a disappointing end to this live. I'm very sorry, but you've seen a troubleshooting process. You've seen someone try to solve problems. There are still more things I can do, but the reality is probably going to take me hours, and I need to be concentrating rather than trying to talk at the same time. Yeah. I've been trying to get my 3+A to run Chromium in the last couple of days, but apparently it doesn't work. Chromium works fine on mine, which is all I can tell you about that. Alexa, stop. Yeah. That's it. That's as far as I can go for now. So thank you everyone for joining me. Really sorry to end on this slightly low note, but let's look at the positives. The sizing is okay. This little device here, I'm going to take off the mirror box, we don't need that. This little tray here, which holds the entire power circuitry, I'm quite pleased with how neat that is. We got the battery in there. I just need to get a switch in here so it works properly. That's just rebooted now into... why did that reboot? Did I shake something? I probably shook something. But yeah, so the power systems work. The battery works. No errors. I've been running much of this live with it assembled. So probably run for the last half hour at least on battery power alone. so that's not bad going either. Someone asked about Chromium running on it, so I'm going to quickly see if Chromium will work. I know it will because I've run it before. Oh, I just shook it and it rebooted. There's a loose connection in there somewhere. That's to be expected. Probably this wire. Let's twist that together a bit better. There we go, loading up again. So we'll just see if Chromium works, which I'm pretty sure it does. I've had it running before. It should just work natively. Might be a little bit slow because we've only got half a gig of memory in this. Again, don't worry about the flashing. It's literally just my capture board. It's not the Raspberry Pi itself. So here's Chromium. Click on there. And I'll probably find it doesn't work. Give you a moment. This is quite memory intensive, so it does take a little bit to load up. It's going to prove me wrong on live now, isn't it? So you can say, no, I don't work anymore. There we go. There's Chromium. Not the fastest thing you'll find on a Raspberry Pi 3 Plus. There are other lighter browsers you can use, but as you can see, it is loading and you can do a bit of browsing on the web. What capture card I'm using a mirror card, which is just a USB 3 HDMI capture board, so it's nothing particularly special. In the way I do with everything, it was the cheapest, most effective thing I could find. But yeah, as you can see, Chromium works. If you don't have Chromium working on your 3A Plus, I would recommend reflashing your SD card, sudo update, sudo upgrade, then try it then, and it should work fine. But I suspect you have an operating system issue or a software issue rather than a hardware issue limiting it. Though, as we've seen from this complete idiot, it does help if you turn your Wi-Fi on. So I spent a lot of this live trying to troubleshoot, not being able to download things, and I reflashed the card and I did not type in my Wi-Fi details again. So that was me being a complete brat. So human, idiot behind keyboard error is always a possibility, which is quite frequent in my case. But yeah, you guys have seen me assemble this thing. You've seen me assemble it. You've seen it working on battery. You've seen that the pieces fit together quite well. The only thing I'm missing from this is M2.5 screws. What this should have done is just screwed in through the bottom directly into the stand, and that's how it was all supposed to come together. I did order some. It's over a week late. They reckon it's going to take even longer, and I'm down to very little funds, so I can't just go and buy some more at the moment. So I'm going to have to wait for those to turn up or refund. But yeah, once I've polished this off and confirmed that this screen is working, yeah. I'm sorry you've tried all that and nothing is working. I don't know why Chromium would not be working on a Raspberry Pi 3A Plus. It works fine on mine. I've got two boards here. They both work fine. I've had it running on a Raspberry Pi 02W as well. No problems there. The only thing it doesn't work on is a Raspberry Pi Zero, where it will work, but it will be incredibly slow, and you've got to leave it for about 5 minutes before it stops working. But other than that, I really can't tell you why Chromium wouldn't be working. You can try other web browsers. Go to software package, do a search. There's plenty of other web browsers you can try. It may be a light issue. I suppose it might be a case if you have your RAM configured, so you've diverted RAM from your main system RAM to GPU, then that might cause Chrome not to run because it doesn't have enough memory. So check your graphics settings. Make sure you haven't shunted over 256 megabytes of memory to the GPU or something, because RAM on the Raspberry Pi 3A Plus is very tight, and you do need to make sure that you haven't just slammed it all somewhere else. I'm not saying you have, I'm just saying it's the only other possibility I can think of off the top of my head, to be honest. So, yeah, I think that's about it, guys. Thanks for coming by. Hopefully I will come at you with another video saying I did this stupid thing and that's why this wasn't working. If that's the case, then check my TikTok, check my YouTube channel. So again, that's youtube.com/@CKenthusiast. You will find this video uploaded there as well for anyone who wants to come in at the beginning and see the whole the whole build process. But I consider this 90% success. I suspect this display is broken in some way. It hasn't exhibited these problems before. Maybe I was a bit rough trying to seat it. Watch the live, you'll see me trying to settle things and bending pins, and it may be the GPIO. Lots of possibilities, but basically I'm going to go and troubleshoot it off screen and try and work out what's going on here. So thanks everyone for joining. I hope you have a fantastic new year. Thank you for sticking with me this long. Your support really does help boost this channel and keep me coming back generating more content. So thank you guys again and have a fantastic new year.